Well, welcome everyone today to the Creo Parametric Flexible Modeling demo. Today we'll look at the Flexible Modeling Extension set of Creo Parametric. First off, for everyone that has not seen Creo, the interface is something you'll probably recognize as being a little different from previous versions of Wildfire Pro Engineer, using the Microsoft-looking toolbar. So we have the ribbon across the top, panels across the top, several shortcut toolbars, one in the middle, one in the upper left, and one on the lower right, and some others around the screen. A lot of this can be tailored to your liking as far as creating new panels, new icons. And it's a common theme through all the Creo apps, whether it be Parametric, Direct, Simulate, Layout, etc. They're all going to use the same common theme, the same common ribbon, other than the commands being different for each individual app. Okay. But on to the Flex Modeling. What we have here basically is an assembly of a car, and some of this car has actually been designed in Creo, some of this has been designed in Parametric, and some of the parts actually have come from third-party vendors. Those vendors may have used Creo, or they may have used other CAD packages. And just like in the real world, not everything is perfect. So when we come into those instances of something that's not perfect, how do we handle those? And with that in mind, looking at this car, we have a part underneath the car. I see there's a boss on one surface, a boss on the side. And if I look at this a little more closely, I can see there's an interference fit on the main part of the body of this subassembly. So how do we address this, especially if this part that we're looking at was created from a third party in a CAD package that we don't have in-house? So this part, as I see, showing my model tree on the left, there's no history. It's an imported part. It was designed in another CAD package, not Creo, not Pro Engineer, and importing as a step file. It could be imported as an IGES file, or maybe you just open that file natively directly into your Creo app. So the question becomes, what do we do? I need to have this addressed. What are my options? I'm limited on time, and it had to be done yesterday. Well, historically, I'd probably have to call the vendor or the third party, have them recreate this, send it back to me, which could take X number of hours, days, etc., or it would rely on me having a license of that other piece of software in order to open this, manipulate it, and then bring it back in again. But if you have Creo, and if you have the Flexible Modeling Extension for Parametric, things are a little different. And that's what we're going to do, is we're going to look at that. So we have several things we need to address. We have some bosses in the wrong spots, some diameters are incorrect, some surfaces that are incorrect, some rounds are incorrect, and there's other things we'll look at too. Now let's look at this boss on the lower right first. It's in the wrong spot. As I mouse over my model, I see the whole model is actually an imported feature. But if I go to my flexible modeling tools, it'll enable me to recognize certain elements, certain geometry, and be able to dictate that as a feature or supposed feature, and then I can use several transform tools, either freely, conceptually, or I can make them constrained and move them about the shape, different places, modify their analytical data, a variety of different techniques, the different options you have to change, manipulate. As what I did here, easy as 1, 2, 3. I grabbed the shape, I moved it up, rotated it, moved it back onto the upper surface, and done. Was able to move it that easy, that quick. And the other thing I'll see in the model tree on the left, I created a feature. So not only did I recognize something, I made a feature from it. So I could go back and edit it. It's there for downstream use. I could suppress it. I could delete it, a variety of things. Now that was a conceptual move. Someone may say, well, what if I needed that to be an exact move? 90-degree rotation, 1.2 units from the front, etc. Well, let's look at that exact move. In this case, what I'll do is delete this feature I created, returning it back to its original state. Now with it back in its original state, let's repeat the actual move itself. So again, I use the recognition tools, recognize my actual, in this case, elements that I want to move, and then I'll do a move again, but in this instance, I want it to be exact, so I'm going to use some references. So I'll say maybe I want to rotate this 90 degrees. And maybe I want to push this in from the side X number of units. And as what I see here, I'm creating moves, steps, if you will. And if I look at my menu, I can see I have steps from what I've actually created that I can go back and adjust, I can tweak, I can change at any given time now or downstream. Again, very easy, very flexible to use, and it not caring what CAD tool it came from, it being very CAD agnostic in a way. Now let's look at this boss here on the left. Now let's say this was incorrectly designed as well. It shouldn't have this chamfer. So again, what are my options? Well, with flexible modeling, let's just substitute it with the correct surface, or remove it. Well, maybe this upper cut isn't correct. Again, let me remove it or substitute it with another surface. Now one may even say, what about the diameter? Maybe the diameter of the hole isn't even correct. Well, let me look at the analytical data of the hole, changing its geometry, and I can update it. Again, very easy, very simple to use, and I'm creating history. I see it in the model tree on the left. Now, looking at the two bosses, I can still see there's a discrepancy. So one may say, well, you know what, let's just remove the boss in the lower right. So let's go remove that boss. Again, same type of scenario. Let me recognize this boss, or the element that I want to remove in this case, whatever that may be. Maybe it's a boss, maybe it's a different surface with a round or some other element, but I'm going to remove it. Again, creating history, so I did retain it. It's still here, but I removed it, but it's a feature called remove. Now, for the other one on the other side, I'm just going to use a flexible mirror move. And in this example here, I already created a datum plane that I'll use as my center axis or center point to mirror this over. So let's go identify the element that I want to move first in this case. Well, I'll say it's this boss. Maybe it's the cut in here. We'll grab the rounds on the outside. And then I'll do a move. Or I'm sorry, I do a mirror. And I'm going to make the mirror about this datum plane that I already created. And easy as that, mirroring it from one side to the other side. Again, creating history. So very flexible, very easy to use. And it being what we call CAD agnostic, it doesn't care what CAD this part was designed in, what CAD package. And if it was an imported part, step file, IGES file, or it opened directly, it doesn't care, very CAD agnostic. Now another problem I had was an interference fit. The upper part of the middle of the upper part or middle part of this part on your screen doesn't have the right radius. Well, I can kind of do the same thing again. I can grab this surface and just change it to that right radius just by dragging it, and I can see how the surface interacts with each other. And I did mention maybe there were a few rounds that we weren't supposed to have. So looking at this side, maybe these rounds were not supposed to be here. And it'll, again, create a feature, but it understands, it's seeing that history that's underneath of the actual part. Again, maybe the round here on the end, maybe it had the wrong radius designed in it, and I needed to put in the correct radius. So it's very easy, very flexible tool to actually use within the manipulation of this part. Now, that was all showing things about working with an imported part, but it also works with features that you do create in Creo. So for example, let's say this part was supposed to have an opening in the side. So I'm just going to make a basic cut here. And one thing about Creo, there's a lot of shortcuts, a lot of tools you can use right at your fingertips to make several steps, several commands very easy, from 2D sketching to 3D geometry, to a variety of different ways to constrain your shapes, draw different models. Very flexible, very easy to use. We're not really going to get into that in this example. I'm just kind of illustrating it here as I sketch this circle, and as I can just drag this from a positive extrusion to a negative extrusion here in this case, making a cut through my shape. Now, I purposely did this so the geometry doesn't match. Now, in the design of this lower step should be in line or parallel or aligned with the light gray curved step inside. It's not. So how to address that? I could use flex tools, or I could edit the extrude, edit the actual sketch. Well, I'm going to use the flex tools. I'm just going to say, well, this surface here, really, I don't want it, whatever distance this is from here to here, 0.14, let's just make it 0, dragging that surface up. And easy as that, it aligned those two surfaces, again, creating a feature. Now you may say, well, what about the original extrude? What about the original sketch? Still maintained. So if I edit it, here's my original extrude. I could go back and look at the original sketch, further modifying it. It's retaining all of the information here as history, so you can go back in time, look at where it was previously before you go to the next step moving forward. Now, looking at this, looks like we pretty much addressed all of the issues with this part here internally. Let's go back to our main model and look at another part, because maybe there's some other elements that we need to address that need to be changed just slightly. So looking at this part here, a lot of pieces designed in Creo, some in other places, but Let's say we need to manipulate a few things here. I need to actually move this boss or make a copy of this boss, and I want only the lower half to hang over the edge. So how would I accomplish that? Well, let's use our flex tools again. In this case, I'm going to recognize this actual element. I'm going to recognize different parts of the element. And a lot of it is to understanding what to recognize, understanding how the part was actually designed as to the way it reacts. Now at this point, it looks pretty good, but I actually want to split this. So there's several tools that you can actually come in and change this, creating different edges, creating different solutions by a variety of different ways to, a variety of different options you choose in this case. So what I'm looking at here is, let's say I made an option. I'm going to keep my original, so I make a copy, but the copy, I'm going to cut at that top flat surface and solidify it. So again, another variety of options. You can even pull things off the shape. You don't have to attach them now. So maybe this boss here, or this element, I want to actually move, but not kind of place just yet. I want to detach it, and then I'll reattach it at a later point. So I'm just going to push this over, complete the command, made a copy of it, and oh, I don't want to attach it just yet, but then when I'm ready to attach it, maybe I can use my attach feature and just reattach it. Again, what I'm doing is creating history, so if I look at the bottom of my model tree, everything I've done, I've added history. So I could suppress it, delete it, roll it back if I wanted to see previous elements that were designed. Now, in the previous example, I showed how I can thicken and raise that flat surface to be in line with the other surface. But let's say we have a part such as this one that the actual surface of this edge isn't the correct thickness, and I want to thicken it or thin it. And you can see I can drag it, but let's say I don't want to mess with this inner boss or this inner part. I want to break it so I don't actually thicken this all in one step. Well, again, there's a variety of different ways I can come in here and control my different movements for what I'm selecting, what I'm actually flipping and controlling, to have different elements, different solutions based on what you started with. So here I was able to just break that away and only thicken the outside. Now you also have other tools too. If I want to control where edges are bound at. So here I'm actually binding this on the outer edge, and I'm dragging along the center sphere, but I can go along an axis, I can go along a datum plane, a variety of ways you can actually do this. But let's say I don't want to bend it where those points are at. I want to make a different, let's say, surface in this case, where I'm going to hinge this. So I'll hinge it maybe here. Let's put it over a point here, and now I come up with a different solution. So a variety of ways to manipulate, change different things. Now recognition as well. That's part of this, understanding what it's recognizing, what it's not. There's several rules based in here. So I can look at holes that are coaxial around the surface. I can look at all holes that have the same radius. I could look at holes that have the same convexity. Or I could even look for things that have patterns. Now maybe there's no pattern here, but I can actually recognize elements of a pattern itself. But let's say there was a pattern that was potentially created in the part, in the CAD package it was created in, and you needed to modify it. For example, if we look at this hub, again, just to show in the model tree, no history. But again, I don't have the CAD package that it was created in. I don't maybe do not even know what it's created in, but I need to modify it. Well, I'll use my flex tools. In this case, I'm going to again recognize that element, and I'll say instead of this being 3 holes, it should have been designed with actually 6. So I'm going to use a pattern recognition tool to allow me to recognize the pattern, again, if the pattern's there. And then if it's there, I can choose whether or not I want to edit the pattern. So in this case, I'm just going to do a simple edit from 3 holes to 6 holes, updating the pattern. Now again, a lot of this depends on, too, the geometry of how the part was created initially when I'm recognizing a pattern. If it's not, I may have to use something rule-based to allow me to edit this, looking at holes that have the same convexity, the same radius, etc. But I can see I can manipulate the pattern. Same thing if it's a linear pattern. So let's say if I choose this other part. Again, supposedly there's a pattern here. It's an imported part, so I don't see any history in the model tree. But let's again use flex tools. I need to modify this. Well, I'm going to recognize this right now as a pattern, and as I'm recognizing it, maybe I'll allow the edit. And then I can modify this element. So very flexible, very easy to use, a way of recognizing different elements, different features, etc. within the part itself. So even if what I was mentioning about, maybe not being a theoretical pattern within the tool itself, but wanted to recognize a hole that had the same radius or same diameter. So if I chose this, I could do rule-based. Show me all holes that have the same radius, all have the same convexity, all that are coaxial. So you have a variety of ways to actually use your rules, not only in that example, but other examples as well. And here's another example. Let's say for this front of the part of this car, we needed to add weight by thickening a surface. So looking at this here, I see there's two cutouts. Again, how do I do this if it's an imported part? Do I send it out? Do I modify it? Or, again, use flex modeling. So I can come into my flex modeling, grab my surface. I can do a simple offset if I want to, just grab an arrow, drag it to a given distance. Or let's say if I want to be more precise, I can grab something to another surface, change the geometry, change the actual dimension itself. Everything you do, you create history. So I am creating history here that I can go back, modify at a later date, at a later time, or save it for downstream use so people can actually see what you actually have done, what you've actually modified. So again, flexible modeling, Creo Parametric, very, very flexible to use, very, very intelligent. What we call CAD agnostic. It doesn't care what your part came from, what the assembly came from. It'll recognize history within that part, that assembly, no matter what CAD tool it came from, no matter how it was imported, step file, IGES file, or if it was imported directly. Again, very flexible to use, giving you a variety of options how to manipulate and manage your designs. Again, thanks for everyone for attending the Creo Parametric Flexible Modeling demo today.